So very quickly, this is how we define a flow when the initiators are doing read and write, those transactions or read and write traffic with the targets. In the fiber channel header, we have the initiator and the target ID. The FCIDs of an initiator and the FCID of the target. That goes within the fiber channel header. But the LUN value or the namespace value for NVMe transaction is sitting within the respective header, be it SCSI header or on the NVMe header. So from there, we bring out that value too, and that makes an ITL flow for SCSI transactions. And for NVMe transaction, that makes an ITN flow. Now, if not tomorrow, we'll also talk about that. What happens? Do I have a slide for that? No. So what happens is, let's say somebody wants to figure out that, let's say you want to know the IOPS of an ITL flow, right? Like this is I1, T1, L1. You want to know the IOPS of this. So what you do is like you have an ITL flow for this and you query here. But at the same time, let's say if you want to query, or do I have it here? Yes, I think let's look at this slide. So if I want to know the IOPS of I1, T1, and N2, I query here. And by the way, queries, we'll talk about that, right? Just for the conceptual point of view, you go and look inside this construct. And let's say you want to know the IOPS of I1, T1, and N1. You look here, right? But what happens, let's say you don't want to go at a LUN level all the time, right? You just want to go at a IT level. So for that, obviously you could have I1, T1, N1 flow and I1, T1, N2 flow and take the IOPS of this flow and takes the IOPS of the other flow and do a sum and then find the combined IOPS, right? This would be the IOPS of I1, T1 flow. But imagine in a production environment, you have 500 such ITL flows or ITN flows. So now we're talking about doing a sum of 500 values, not the best thing. And to cover up that gap, what we do is we also define flows very flexibly. So we also define flows as IT flow, or we define flows as initiator flow, or we call it as target flow, we call as LUN flows, we call as TL flows, all kind of combinations that we can ever think of. Right. So the question is, how does it help? A lot of times you just want to know, let's say, show me the IOPS of initiator one. And this initiator one may be talking to 10 different targets, 200 different LUNs, right? So you just go and ask the initiator flow for this initiator one, and you find the answer within one query. That's the value here. And that's how we maintain these different flows, because everybody has a different use case, and not every time, people like to go and do a drill down at a LUN level. That's just too much detail, obviously. Right. So this is the concept, like when we say IO flows, it's a very context sensitive term, even though we keep on saying ITL flows, but really depends. If you're looking at an initiator, you'll see that I'll use the word like initiator flow, right? So this is what I mean by an initiator flow. Or when I say target flow, this is what I mean by a target flow. So let's say in target one and target two, I may be wondering what is the throughput on this particular port on this target port. So I can just query the target flow here, and I get the throughput value here with one command. Otherwise, I have to find all those ITL flows and then figure out where they're going, then take a sum out of it. And trust me, one time I do it, I don't want to do it again. Right. So the concept of a flow is flexible and it's context sensitive, that where you're looking and what value you're looking. Okay, any questions on that? Just looking for smaller topics. I think we got 25 minutes. Let me cover the architecture piece because you already covered this art yesterday, so we can cover this. essentially, again, metric collection and metric export, metric inspection, or say the traffic inspection happens within the ASICs, the 32 gig ASICs. Essentially, the way it happens, I mean, there's nothing really, different in the ASICs, even though externally we like to talk about that. But on the ASICs, we have created ACL TCAM entries, right? And these TCAM entries actually look for the specific fields in the frame headers. Now, what are the fields? We'll talk tomorrow because we don't have enough time for that today. We look for those fields in the frame headers, and then whenever we find a frame of interest, we send it to an onboard network processing unit. Right now, all this frame inspection and everything is happening within the ACL TCAMs, right? So that's why there's no impact to our switching functionality, right? And also because this inspection happens on all the ports because it's part of the basic ASIC functionality. Okay, now what we do is we only strip off the, I think, initial 100 bytes or 120 bytes of exact number, I don't remember, but some only initial portion of the frame that only includes the header. We don't send the full frame, right? And then depending on which switch and which model you're looking, there are internal hardware traces, and the model slightly differs. If you want, we can cover that hardware block diagram. Like somebody had, like maybe Wolfgang, you had that question yesterday that on 96 port switch you have one NPU, while on 32 port switch you have one NPU. So yeah, we can talk about those, hardware diagrams, but that's one internal detail. More importantly, is that we only send the headers to the NPU, and then NPU actually calculates all the metrics. So the metrics are not calculated in the ASIC today. That's something we'll do in the 64 gig ASIC. Right. So a lot of the functionality of the NPU, what we're doing next is we'll be moving that towards ASIC, and that brings us some benefits that probably we'll talk later, right? We need to understand the trade-offs with this architecture, right? Like that helps us to design better today. And then we have taken those learnings and, we're trying to improve that in the future, right? That's how we design, any product, right?
So I do have a question. I may jump a little bit ahead of your presentation, but as I know that we're also taking data for the depth queue, right? So, and this is one of the things I noticed when customers are moving from 8 gig to 16 gig to 32 gig, they take the assumption they can double the fan-in ratio on the storage array, which is not necessarily true because every storage array has its specific limitation. Like for instance, on a NetApp, we have a depth queue of 2048. Is this somehow we can, take into a metric, saying you have to pay attention not to over provision your storage array on that port?
Yeah, so we have a metric for that, which we call as outstanding IO.
Correct.
So yeah, that helps to detect that. And probably tomorrow we'll go in that detail. That's why I left that section for tomorrow full session.
Okay, yeah, perfect, thank you.
But essentially all these metrics, like I've been using these metrics like exchange completion time, IOPS, throughput, what you said about outstanding IO, all these metrics are calculated within the NPU.
But the outstanding IO on a physical port, let's say on a storage array, is that something that is actually exposed somehow from the storage array in a frame or something like that? Or is that something you always have to know?
Yeah, that's a question for tomorrow.
Okay, great. I'm looking forward
we'll walk through that whole,
then.
like which metric is collected from where, right?
Correct.
Like what, where, or which frame, like, I also made the statement that some of the metrics, you don't even have to wait for the exchange to get finished. Right, so those kind of details we'll cover tomorrow.
Okay, great. Thank you.
And finally, the third portion of the architecture is like about metric export. So we also talked about that, right? So essentially all these NPUs within the modules of the switch, we, the supervisor of the director class switch, or, we don't have a supervisor in fabric switches, but the architecture is same, that we take these metrics from the NPUs and we push it out of the supervisor. So the push is happening from the supervisor, but the supervisor still pulls the metrics from the NPU, right? To external receiver for doing some kind of magic. Okay, so quickly, basically, it's all available on the 32 gig products. It's not dependent on the operational speed of the port. It's not dependent on the transceiver that you have on the port. So you can enable SAN analytics on a 4 gig port, use an 8 gig transceiver. All these things are possible, right? And why? Because it's an ASIC capability. It's an NPU capability. It's not really dependent on the transceiver.
Paresh, quick question. You know, obviously, from a director perspective, we have a 4 payload, 8 and 16. Is there any concern about where, like, the 16th payload slot being more latency than slot 1 of a 9718 with regard to analytics at all? Slot placement of cards, is there any one better place than another from your perspective, or is it all treated equally?
All treated equally. Yeah, I think that's one of the basics of our architecture, that all the ports are consistent. Somebody can connect their devices anywhere. Yeah.
But there's no, like, if you're in slot 16, the telemetry in slot 16 out of the NPU has just as much, it's first come, first serve into the DCNM, right? I mean, there's no placement of a line card that's going to be using telemetry. We don't give a damn where it is. Exactly,
yeah,
right?
that's right. Yeah, we wouldn't give a damn. Yeah, it's
okay.
The NPUs. If you go back, look at this picture on the bottom right, Like this is a 8-slot director. So we have 8 NPUs. All of them are working independently. And they're calculating their metrics independently. You know, in a larger fabric, think about like 5 directors, 40 NPUs. All of them are working independently. When it comes to export, the supervisor pull the metrics, send it out. And then finally, all the end-to-end mapping, correlation, all that magic is done within DCNM, right? That rules figuring out the logic.
Thank you. Thanks.
Right. Things like, I think, mapping these things to enclosures, mapping these things to device aliases. Because remember, in the frame headers, we don't carry device aliases, right? Device alias is I would say, kind of a control plane construct. But the data plane carries the FCID. It doesn't even carry WWPNs. So when we have the metrics, and we'll look at the metrics tomorrow, maybe, you know, let me show you one output now that we're talking about it. Just for show analytics query, and when you do select all from FC SCSI dot no SCSI target ITL flow. So this is what the switch exports to DCNM, and we'll cover this detail, right? So don't get lost here. What I'm trying to say is this is what the flow carries: the target ID, the initiator ID. Right now, the LAN is not even, the switch is not even aware of the LAN. But if you look at this thing, this would be somewhere sitting in my FCNS database, right? Show FCNS database, FCID, and oh, what did I do? Oh, vSAN, right? Yeah. So you see that this is my device alias. But only FCNS database is aware of my device alias, or the device alias database is aware of the device alias. The frame header is not. So all this all these things need to come together, while the end-to-end correlation, that's what happens in DCNM. Otherwise, for those of you who remember, in the initial releases of DCNM, we were not showing device aliases. We were just showing WWPNs, and we left it on a customer to figure it out. Wasn't very nice of us, but guess what? We have fixed it.
Why would somebody look to trap 100,000 flows? I think that's not, I wouldn't call that good behavior. I thought the tool, yes, I understand the reason behind the tool, but I thought the tool could be more used for troubleshooting line of businesses versus looking at every damn flow that occurs and being somewhat egregious in that behavior. That doesn't make sense to me, but.
So I have a quick question. I know we talked briefly about the flow types. Do the types of flows, are they a logical construct built on ITL? Or if I get an IT flow versus a target flow versus an I flow, does that reduce my overall requirement to push out that combined data to DCNM? Or does that just have no bearing other than how I query it?
Yeah, so that's a logical construct. It's a tree-like structure. We'll go into super detail of that, but essentially, we don't separately maintain higher level flows, right? So ITL is what we export to DCNM, but the switch also have IT flows and T flows and I flows, and it just uses the ITL flows to build that information.